Have you ever turned on a fan using a regulator? You can control the speed of the fan, right? But do you know how it works? It all comes down to electricity. Voltage is like the pressure that pushes electricity through a circuit. Higher voltage means more electricity flows. Current is the flow of electricity, like water flowing through a pipe. And a resistor is part of the circuit that slows down the flow. Now here is something interesting. The amount of current increases when the amount of voltage increases, which means they are directly proportional. But if the amount of resistance increases, the amount of current decreases. This means current and resistance are inversely proportional. This is exactly how the fan's regulator works. By changing the amount of resistance, you can control the current and in turn the speed of the fan. We can combine these relationships into a formula called Ohm's law, which is written as I is equal to V by R, where I is the current, V is the voltage and R is the resistance. You can rearrange this formula to find any one of these values if you know the other two. But what does this have to do with simplifying algebraic terms? Well, if you don't know how to multiply and divide terms properly, you won't be able to rearrange formulas like this.
Sir, so multiplying and dividing terms only applies in electrical engineering, right? But I want to be a mechanical engineer. I don't have to study this. I'm going to play.
Oh really? Well, let me show you how it is used in mechanical engineering too. You know the equation of motion, right? V is equal to U plus AT. That's all multiplying and dividing terms.
Okay, but that's just one example.
Oh, there is more. Ever heard of the slip of a vehicle? Or the drag on a car caused by airflow? Even the time for pendulum to make one swing.
Alright. I get it. I'll stick around and listen. No more excuses.
Now let's go over some rules that will help you simplify expressions that have letters and numbers multiplied together. If the term is ABC, it means A times B times C. Similarly, 3A means 3 times A. We simply multiply variables without writing the multiplication sign. AB square means...
Sir, it's AB2, not AB squared.
It's AB squared. AB square means A times B times B. Only B is squared, not A. You could write ABB, but it's better to use AB squared for simplicity. Note that variables without an exponent have an implied power of 1. For example, A is equal to A power 1. When you see AB whole squared, it means A square B square. Similarly, A by B whole square becomes A square by B square. The brackets mean both the letters are squared. The exponent tells you how many times the letter is multiplied by itself. So A times A times A times A is written as A power 4, not 4A. Let's check your understanding. Example 1. Simplify P times P times P times P times P times P times P. When a variable is multiplied by itself several times, we use index notation to simplify it. So it becomes P power 7. Example 2. Simplify m times m times m times n times n times n times n times n. This can be written as m power 3 n power 5. Example 3. Simplify 5 times t times t times 7 times y. First multiply the numbers together. 5 times 7 is equal to 35. Then simplify the variables. T times t is t squared, so it becomes 35t squared y. Apart from these basic rules, you can also apply power rules when simplifying algebraic expressions. These rules help us simplify expressions that have powers or exponents. Let's go over them one by one. Multiplication using indices. When you multiply terms with the same base, the powers are added. Example, x power 4 times x power 2. What does x power 4 mean? It means x times x times x times x. What about x squared? It means x times x. Now it becomes x times x times x times x times x times x, which is x power 6. So multiplying x power 4 times x power 2 gives us x power 6. And notice how we add the powers. 4 plus 2 is equal to 6. So when multiplying, you add the powers. Division using indices. When you divide terms with the same base, the powers are subtracted. X power 5 divided by x power 2. What does x power 5 mean? It's x times x times x times x times x. And x squared, that's x times x. Now it becomes x times x times x times x times x divided by x times x. 2 of the x's in the numerator cancel out with the 2 of the x's in the denominator, leaving x times x times x, which is x power 3. So x power 5 divided by x power 2 simplifies to x power 3. And notice how we subtract the powers. 5 minus 2 is equal to 3. So when dividing, you subtract the powers. Power of a power rule. When you raise a term with an exponent to another power, you multiply the exponents. Example, x power 3 whole power 2. What does x power 3 whole power 2 mean? It means x power 3 multiplied by itself. X power 3 times x power 3. Now let's break down what x power 3 is. It's x times x times x. So x power 3 whole power 2 becomes x times x times x times x times x times x. When we multiply all of these together, we get x power 6. So x power 3 whole power 2 simplifies to x power 6. And notice how we multiply the powers. 3 times 2 is equal to 6. So when doing a power to a power, you multiply the powers. Let's check your understanding with a few more examples. Example 1. Simplify 3 power 2 times 3 power 5. This is a multiplication of terms with the same base. So we apply the multiplication rule. What do? Add the exponents. 2 plus 5 is equal to 7. So 3 power 2 times 3 power 5 is equal to 3 power 7. Example 2. A power 7 divided by a power 3. This is a division of terms with the same base. So we apply the division rule. What do? Subtract the exponents. 7 minus 3 is equal to 4. So a power 7 divided by a power 3 is equal to a power 4. Example 3. Simplify y power 4 whole power 2. This is raising a power to another power. So we apply the power of a power rule. What do? Multiply the exponents. 4 times 2 is equal to 8. So y power 4 whole power 2 is equal to y power 8. Algebraic fractions. If you got a fraction with variables and numbers, you might be able to simplify it. The process is similar to reducing regular fractions. First we divide the numbers. Then we look for the variables that are common in both the numerator and the denominator and cancel them out. When we cancel variables, we are actually dividing by those variables. Let's look at some examples to understand this better. Simplify 6a by 2. First divide the numbers. 6 divided by 2 is 3. Since there is no a in the denominator, the a remains. So the answer is 3a. Simplify 15xy by 3x. Start by dividing the numbers. 15 divided by 3 is 5. Now look at the variables. Both the numerator and the denominator have x. So we can cancel them out. The y stays as there is no y in the denominator. Simplify 15c cube divided by 5c. Divide the numbers. 15 divided by 5 is 3. Now look at the variables. You have c cube in the numerator and c in the denominator. Cancelling c from both is like subtracting the powers. 3 minus 1 is equal to 2. So we are left with c squared. So the answer is 3c squared. That's a key rule to remember. When dividing terms of the same base, subtract the exponents. Simplify 2e f power 3 whole power 2 divided by f power 2. Start by squaring everything in the numerator. 2 squared, e squared, f power 3 whole squared divided by f squared. 2 power 2 becomes 4, f power 3 whole power 2 becomes f power 6. Now simplify the fraction. Since both the numerator and the denominator have f, subtract the exponents. 6 minus 2 is equal to 4. So the answer is 4e power 2 f power 4.
If I didn't know how to simplify terms, I wouldn't have made this amazing innovation in electrical engineering.